Hello and welcome to Mathematics with Simon. I'm Simon. We recently made a video on partial fractions, but Andy Robertshaw pointed out that there is a alternative and actually, I would say actually better, quicker way of solving these problems. He also pointed out another interesting point about improper fractions, which strictly speaking won't crop up in the A-level syllabus, but we thought we'd include it anyway because mathematically it's very interesting. So just to recap then, so we learned how to subtract fractions, a third minus a quarter, put them over a common denominator, so you end up with 4/12 minus 3/12, which is 1/12, and we can then generalize this to algebraic fractions, so 1 over x plus 1 minus 1 over x plus 2, put them over a common denominator, which is over x plus 1 x plus 2, so you get x plus 2 over x plus 1 x plus 2 minus x plus 1 over x plus 1 x plus 2. Subtract them, you just get 1 over x plus 1 x plus 2, and the interested viewer will notice that if you substitute x equals 2, you get this. But if you substitute other values of x, you get other things. Like if you put x equals 1, you get a half minus a third equals a sixth. And of course we can go the other way. So if someone gave us 1 over x plus 1 x plus 2, we're going to split that up into a over x plus 1 plus b over x plus 2. And this is the alternative method that Andy reminded me of, which is that if we put them all over a common denominator, x plus 1, x plus 2, and then we're going to equalize the numerators. On the left we've got 1, and on the right we've got ax plus 2 plus bx plus 1. And all we do then is substitute in x equals minus 1, which basically makes the right-hand term equal to 0. So then you just literally get 1 equals a plus 0, because like if x is minus 1, that's a times 1, it's just a, and then on the left you've got 1, and then the bx plus 1 term disappears when x equals minus 1. So you just get a equals 1, and then if we substitute in x equals minus 2, that then removes the a term in the numerator, and we just get minus b equals 1, so b equals minus 1, so a equals 1, b equals minus 1, so the answer looks like this. Very good. And just to recap, the reason this matters is because if we were integrating 1 over x plus 1 x plus 2, we could rewrite it as the difference of two integrals, 1 over x plus 1 over x plus 2, and these are known. These integrals are known, so it's log x plus 1 minus log x plus 2, or log x plus 1 over x plus 2. So partial fractions are useful in many contexts, but integration is the one that's most obvious to me, and it's a big, powerful application. So another way, let's look at another one, 7x squared plus 10x plus 1 over x plus 2 squared. This is a more complicated one, times x minus 1. So here we resolve it into three fractions, something over x plus 2, something over x plus 2 squared, to deal with the squared factor, and then something over x minus 1. So if we multiply through, put that over a common denominator, we're going to again equate numerators on the left and the right. So here we've equated the numerators and actually just turned it around. So firstly, if x equals 1, the term with a disappears, the term with b disappears because you get a 0 in there multiplying them. And then you get 3 squared is 9 times c equals 7 plus 10 plus 1, which is 18. 9c equals 18, so c equals 2. Put in x equals minus 2, we get the first term disappears, the c term disappears, but then you get minus 3b. And with x equals minus 2, you've got like 28 minus 20 plus 1 is 9. Minus 3b is 9, so b is minus 3. And then we pop in x equals 0 as the last one, which is the most natural. I mean, minus 2 was natural because it makes certain terms disappear. 1 was natural, and then there are no other numbers that will make any terms disappear, but 0 is a really easy one. So you put in 0, we get minus 2a minus b plus 4c, and that equals 1. And we know that c is 2. We know that b equals minus 3. We can substitute those things in, and that's going to tell us that a equals 5. which is all pretty. So then it can be resolved this way: 7x squared plus 10x plus 1 over that equals 5 over x plus 2 minus 3 over x plus 2 squared plus 2 over x minus 1. We're going to try a simpler one here. This is difference of two squares. We did all of these in the last video. We're just doing them via this alternative method. Because in the last video, what we did was we got some simultaneous equations by equating the coefficients of the polynomials in the numerators on the left and right. And what we're doing here is substituting in for different values of x. And that allows us to solve because it just kills off certain terms. So 8 equals a x plus 2 plus b x minus 2, because basically we've multiplied the top and bottom of this fraction by x plus 2 and the top and bottom of this one by x minus 2, and then you get x squared minus 4 as a common denominator, because x squared minus 4 equals x minus 2 times x plus 2. So 8 equals this thing. Put in x equals 2, you get 4a equals 8, a equals 2. Put in x is minus 2, you get a 0 here, and then you get 8 equals minus 4b, b equals minus 2. So basically 8 over x squared minus 4 equals 2 over x minus 2 plus minus 2, or kind of minus 2 over x plus 2, or plus minus 2 over x plus 2, depends how you want to do it. And again, that would be, both of these terms can be integrated on the right hand side if that's what you're trying to achieve. Now, Andy made the point that where we get an improper fraction where the degree of the polynomial of the numerator is higher than the degree of the polynomial on the denominator, we need to do a polynomial division. We've got a video on polynomial division if you're interested. And that's a really good point. I don't think that will happen in the A-level syllabus, because I think in the A-level syllabus the numerators are like first order or lower. But just as mathematicians, it's good to know this. So we carry out the polynomial division. So we divide 2x cubed plus 5x squared plus x minus 5 by x squared plus x minus 2. I'm not going to go through the details of this division. Well, come on, I will. Come on, why not? So basically what we do is x squared plus x minus 2. So firstly into 2x cubed. So x squared into 2x cubed goes 2x times. Then we multiply 2x by x squared plus x minus 2. So you get 2x cubed plus 2x squared minus 4x. Then what we're going to do is subtract the 2. So the 2x cubes cancel. That's kind of the point. Then you get 3x squared, and then you get x minus 4x is plus 5x. Then you bring down the minus 5, 3x squared plus x minus 5. Then x squares into 3x plus 5x minus 5 goes in just 3 times, plus 3 on the top. 3 times that, you get 3x squared plus 3x minus 6. Take them away, we get 2x plus 1 as the remainder. So what that means is we can rewrite this fraction on the top as 2x plus 3, which is sort of the bit, the kind of complete bit that came out as a quotient. And then the remainder we still leave over x squared plus x minus 2. We leave the remainder over the thing we were dividing by. And then this bit we need to resolve by partial fractions again. So 2x plus 1 over x squared plus x minus 2. And I've configured this so that it comes out neatly. So the first is x squared plus x minus 2 factorizes into x plus 2 times x minus 1. Because if we do it, x times x is x squared, then you get 2x minus x is plus x, then you get plus 2 minus 1 is minus 2. So it comes out like that, and then you've got a over x plus 2 plus b over x minus 1. Like this, we're just rewriting it. Again, what we're going to do is we're going to equate the numerators. So what this comes out to is 2x plus 1 equals a times x minus 1 plus b times x plus 2. Firstly, we put in x equals 1, which gives us that 3 on the left equals 3b, so b is 1. The next is we put in x equals minus 2, and then what we get is minus 3 on the left equals minus 3a, so again a equals 1. So to summarise, 2x cubed plus 5x squared plus x minus 5 over x squared plus x minus 2 equals 2x plus 3 plus 1 over x plus 2 plus 1 over x minus 1. So again, if you had to integrate this thing on the left, you could turn it into this, and the right hand side is quite easy to integrate. We all know what it is, right? Integral of 2x is x squared, integral of 3 is 3x, integral of this is a natural log of x plus 2, integral of this is natural log of x minus 1, and then if it's the indefinite integral, we add a constant. I really hope you like this video. If you do, please feel free to hit the like button. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas. Lots of people have been sending me ideas, which is very kind, or also just comments or corrections, and those things are equally valuable, of course, if not more valuable. So we hope you enjoy your mathematics, and see you soon.